Hi everyone, welcome to our video on where we're doing partial derivatives, but we have another variable thrown in, so we've got lots of variables now. Alright, so it's still pretty much the same thing, it's just there's more variables, and so whatever the variable that we're doing the derivative with respect to, we treat as a variable. All others are treated like constants. Okay, so let's break this down. So let this function here, and this function, so they're using x, y, and z, so no longer z's just on the left. They might say like this is w equals this whole function. Okay, I prefer it. This function notation I think is a little better though. Okay, anyway, so let's stick to this. And then they want us to find the first order partial derivative of each letter, x, y, z, and then they want us to find the second order derivative, which is x, y involved. All right, well, let's do that. Okay, so I'm going to do this one first here. Okay, so this is doing the derivative with respect to x. So x is our variable. So we have f little x, x, y, z is equal to, okay, so looking at this first term, the derivative of, let's just write the constant, there's 4. X squared's derivative is 2x, and then y and z are just constants that are attached. There we go. And then in the second one, we have minus 3. The derivative of x is 1. And then z is just a constant that's attached. There we go. And then the second one, or the third one, I mean, we see we have got an x to the 4, so it's plus 18. The derivative of x to the 4 would be 4x cubed, and then y is attached, just like that. Okay, and then now it looks like all we have to do is simplify the first partial derivative with respect to x. This first term looks like it becomes 8xyz. And then we have minus 3z. And then this one is 72. So plus 72x cubed y. Okay, so no big deal, right? If they throw lots of letters at you, just kind of blur them out or just think of them as constants. Okay, so step 2, or number 2, is the partial derivative with respect to y. Okay, so I'm back looking at the original function. Let's write our notation down. Okay, so looking at the first term, I see a y in it, so I'm going to copy 4x squared. The derivative of y is 1, and then let's copy z attached to it. And then the second term does not have y, so that means its derivative is 0, because it's treated as a pure constant. And then the last term does have a y in it, so let's write the 18x to the 4. The derivative of y is 1. And then just like the first part of the problem, I'm just going to simplify. This is 4x squared z plus 18x to the 4 is how that simplifies down. That's it. Okay, just moving right along. All right, number 3. Let's do that one in green. So the first partial derivative with respect to z. All right, well, I'm looking at this function still. I have a z in the first term. So let's copy 4x squared y are constants. The derivative of z is 1. And then we've got minus 3x. Z's involved in the second term. The derivative of z is 1 again. And then the last term doesn't have z in it, so that means its derivative would be 0. And I'm just using a placeholder. Okay, and then so we've got it. It looks like it's 4x squared y minus 3x. There we go. All right. Okay, and then so that was the third one. So we did the first partial derivative with respect to z down there in the green. And then one more. Let's do it in purple here. Oop. Let's scroll. It freaked out for a second. Okay, so I've got number 4. Let's put that right here. Okay, so this 4 means we wanted to do the derivative with respect to x first. So that's this one. Let's just go ahead and copy that. Okay, so that's 8xyz minus 3z plus 72x cubed y. So we needed that first. And then now we're doing it with respect to y. So f little xy, x comma y comma z equals, okay, so the derivative of the first term with respect to y is 8x, and then the derivative of y is 1, and then z's attached, and then minus the derivative of this one with respect to y would be 0, and then plus the derivative with respect to y over there is 72x cubed. Derivative of y is 1. Okay, and so now we've got our final answer. If we simplify it a little bit, we've got 8xz and then plus 72x cubed. Okay, so that's it. So we found it. There's one way, let me just put it in orange. This should equal that as well. All right, so that would mean take this one and do this derivative with respect to x. So I'm just going to do a quick check. All right, so the derivative of this with respect to x, the 2 would times the 4 to give us 8x, and then z's attached. And then the derivative of this with respect to x is 72x cubed. Yep, it checks. So remember, the order here doesn't matter. I mean, when we do the steps, it goes in that order, but the answers should be the same. So that's one way to check your work. Okay, so that's if they throw however many letters they want to throw in there, that's fine. It's really just one letter is the focus at a time, though, for the variable. All right, let's do one other scenario that they like in these types of problems, where they give us a function, and then they're saying find all values of x, y, and z such that the partial order derivative with respect to x is 0, and then this one's also 0, and then this one's also 0. Okay, so what it really is step 1, let's just find our first order derivative with respect to x, and afterwards we're just going to set it equal to 0. So let's find it. So that's looking at this giant equation here. All right, so the derivative, it looks like it would be 2. The derivative with respect to x is y, so it's 2y. And then minus the derivative of this one with respect to x would be z, like that. And then plus the derivative of this with respect to x is 0, so plus 0. The derivative of this one with respect to x is 8. The derivative of the last one with respect to x is 0. Okay, so what we have is our first order partial derivative is 2y minus 9z plus 8. And then they say, hey, this, now they just want to set equal to 0. So they're saying set that whole thing equal to 0. So we have 2y minus 9z plus 8 is 0. So it's all set up just like this. Okay, and then let's cloud that. We'll keep that around for a little bit. Okay, so we need to do the others as well. So let's do step 2. So now let's get the partial derivative with respect to y. Okay, so looking at this, the partial derivative with respect to y looks like it's 2x. And then we've got minus, the derivative of that is 0 if it's with respect to y. The second term is 0. The third term with respect to y would be plus 12z. And then the derivative with respect to y of the 8 is 0. 8x is 0. The derivative of that one with respect to y is also 0. Okay, so it looks like we have our partial derivative as 2x plus 12z. And then they say, okay, so now set this. They're saying set it equal to 0. So 0 equals 2x plus 12z. And let's cloud that. Okay, and then the last one, let's do that in green. Okay, so the last one is, let's get the partial derivative. Okay, so step 3 here with respect to z is, all right, so the first term's derivative would be 0 because there's no z in it. The second one would be minus 9x because the derivative of z is 1. And then plus the derivative of this is 12y because the derivative of z is 1 again. The derivative of 8x with respect to z is 0. The derivative of negative 15z would be minus 15 with respect to z. There we go. Okay, and then we'll clean it up. And it becomes negative 9x plus 12y minus 15. And then they say again, hey, just set that equal to 0 equals negative 9x plus 12y minus 15. Okay, so now we've got these equations. And at this point, it's really a system of equations where we're going to rewrite all of these. Okay, so on this first one, if I were to minus the 8 over, it would become 2y minus 9z equals negative 8. And then on this one, it's already ready, but let's put, so here's my x, y, z constant is how I'm setting it up. Okay, so on this, I've got 2x. There is no y, so just leave a gap, and then plus 12z equals 0. And then this last one, if I add that 15 over, we could write it as negative 9x plus 12y equals 15. Okay, so this here, we've got a system of equations. And then typically we use a calculator to solve this in the form of a matrix. So this becomes 0, 2, negative 9, negative 8, and then 2, 0, 12, 0, and then negative 9, 12, 0, 15. All right, and with this, so this is our matrix. So I'm going to use Desmos again. All right, so we're on Desmos. Make it the full screen. Oh, let me see if I can show it. There we go. Okay, so the full screen, you can go to Math Tools and the Matrix Calculator. And then with the Matrix Calculator, we could type in the matrix, and then we can increase the rows and columns so we have the same match. And then now I'm just going to type those in. So I have 0, 2, negative 9. Oops. Sorry. Okay, so 2, and then use the arrow. Oops. Sorry. 0, arrow, 2, arrow, negative 9, arrow, negative 8, arrow, 2, 0, 12, 0, negative 9, 12, 0, and 15. Okay, so we've got this matrix right here. Okay, and then with this matrix, okay, so there's some functions that we can do with it. Let's see, where were they? Not projector mode. Okay, so I've got my matrix. There we go. Okay, oops. So I just clicked over to the side next to it, so where it was like that, and then let's go RREF on our matrix A. Okay, and then that way it's going to give us our answer. Let's change it to fractions, and it looks like this. Okay, so all I did was I typed in the matrix, got it all ready. And then RREF is row reduced echelon form is what it means, but it tells you what each of these is. So this is now X. Okay, and we might remember that from Business Math 1. All right, so these were the X, Y, Z's, and constants. And then we did RREF on it. We'll put it right here, RREF. And we got a new matrix, which had these diagonal ones on it. And then we had negative 7 halves. We have negative 11 eighths. And then we have 7 twelfths. Okay, and what this means for our answer, so there's x, y, z, and these are the constants. Well, what it means is you have one x that equals negative 7 halves. So x is negative 7 halves. On this, we have y equals the negative 11 eighths. And then the z is equal to 7 twelfths. So it just breaks down each line. And then for a final official answer, we usually put it as an ordered triplet. So we would have negative 7 halves, negative 11 eighths, and then 7 twelfths. So it's always x, comma, y, comma, z. And there it is. Okay, so those are the values for x, y, and z, such that all of these partial derivatives would satisfy and be equal to 0. You could plug these into each of these equations to verify, but it does work. It would work. All right, and so that's it. So again, Desmos is real nice. It does pretty much everything an 84 would do. Okay, so it's got some things. I guess it's got geometry tools and test practice as well if you want to check it out. Okay, so but it's a great resource. All right, so and this is something that's usually allowed because it is the same thing that's on a TI-84. All right, so that's it. If you have any questions, let me know. Otherwise, thanks for watching.